There'll be situations in which we'll want to solve an equation who has the variable that we're trying to solve for in the radicand underneath a radical symbol. Those sorts of equations are called radical equations. And when we work through solving radical equations, we want to undo the process that would get us to the point of finding the value of x. Now the first thing we want to do is identify where our equal sign is in our radical equation. So our is equal to is right here. Then what we want to do is isolate the radical term. So my radical term is the square root of 4x minus 2. And then after the end of the radical I have a plus 3 and is equal to 6. Well, I want to get the radical expression on a side by itself. So here the first thing we would want to do would be to subtract 3 from both sides. So we'll have the square root of 4x minus 2 is equal to 3. Now what I want to do next is to undo the operation of the square root. And to undo a square root, we want to take both sides to the power that matches the index. Remember, square root is an index of 2. So to undo the square root, we'll take both sides to the second power. But what I do to one side, I have to do to the other side, and that's why we do both sides. Now notice on the left-hand side, the square root of my 4x minus 2 to the second power and square root are opposite operations. So what happens on the left-hand side, you're just left with the 4x minus 2. And on the right-hand side, I actually have 3 squared, and 3 squared is equal to 9. So now I'm able to get at the term that has my letter in it. We will get all the x terms on one side, which we have, and all the not x terms to the other side. So we'll add 2 to both sides. And that'll give me 4x is equal to 11. And then finally, solving for x, we'll divide both sides by 4. And that gives me x is equal to 11/4. Now when we solve radical equations and we get a possible solution for our equation, we always need to check our solutions if we raised both sides of the equation to an even power in the process of solving it. And we did that right here. We raised it both to the second power. So we have to check our solution because it's possible we'll get answers that aren't usable in the original equation or don't satisfy the original equation. Those are called extraneous solutions, and we can't report those as a solution to the equation. So next up, we have to check. And you have to show it on your paper that you checked it so that your professor knows that you remembered to do this step. Also, to make sure that you only report the solutions that are valid. So in the original equation, we're going to take out the x's and replace them with the 11/4. So I have the square root of 4 times, take out the x, and put in the possible solution of 11/4. And then minus 2, and that's where the square root stopped. Then after that was plus 3, and then we want to know if that's going to come out to be the same number as the right-hand side, and the original equation had the right-hand side of 6. Now when checking your solutions, now that you've got all numbers in the expression that you have on the left-hand side and on the right-hand side, you want to use your order of operations to simplify this side and simplify the right-hand side if there's stuff over there, and then compare to see if they're the same. So order of operations, we're going to do inside the grouping symbol first, and inside the grouping symbol I don't have any exponents, but I do have a multiplication. So I have the square root of 4 times 11/4 is just going to be 11 there, and then minus 2, and then plus 3, and I want to know if that comes out to be 6. Well, still under the radical, I need to take 11 minus 2, so that's the square root of 9 plus 3. Does that come out to be the same as 6? Square root of 9 is 3, so 3 plus 3, I want to know if that comes out to be the same as 6, and 3 plus 3 is 6. So yes, that checks. Our x equals 11/4 is the solution to this equation.